I would like to present our work. It's about transfer learning for named entity recognition in historical corpora. We are team Ehrmama, me, Konstantin Todorov, and Giovanni Kolavica. We are related to the University of Amsterdam. So, firstly, I would like to talk about our participation. Some facts about it. So we tackle the named entity recognition and classification problem only. Our submissions include both coarse and fine-grained entity tag types. We used all three languages, so French, German, and English. On average, we end up second on the French and German languages, but unfortunately, we failed to improve on the English language. That is, our results are worse than the baseline results provided by the organizers. Now, a little bit of the motivation behind our participation. This is actually a part of our general study, which is about investigating the applicability of transfer learning on historical corpora. During this study, we actually introduce a modular architecture, which allows us to easily enable and disable different modules, which therefore actually help us analyze the impact of specific pre-trained embeddings. To this end, actually, our focus is on the embeddings change in performance, or of course lack thereof. And just for your information, that we also investigated in the post-OCR correction challenge, and this actually had different results than the named entity recognition. Now, going to the architecture, I will first talk about the embeddings. As I already mentioned, they are the most important in our study. So to the right, you can see the embedding layer. This, of course, accepts the input, which in the case of the named entity recognition is usually sequences of tokens. In there, we have 4 different types of embeddings. We first have a newly trained embedding module, which is initialized randomly and trained from scratch during the training process. We also use the in-domain fast text embeddings that are provided by the organizers. And finally, we also use a BERT model, which is different per language, and it can also be either like frozen and just uses a feature extraction, or we also fine-tune it and compare this against the original model. Now, it must be noted also that those 3 first embedding modules, they work on subword level, whereas the last one works on character level. It uses a BILSTM to encode the representation. Now, the output of this embedding layer, we work on word level. So to this end, we actually merge, we take the means. So for all the subword in one word and all the characters, we take the mean and then concatenate them on top of each other. We tried other approaches, but similar to other findings in the literature, we discovered that this is just the most simplest and most efficient way to go forward, and also provided similar results as other methods. Now, then talking about the task-specific layers, we have a BILSTM, which works on word level, as I mentioned. And then finally, we have a fully connected layer and a conditional random field in the end, where we use the CRF layer to, of course, monitor the transitions between the different tags. This was already proven to work quite well for named entity recognition in the literature. Finally, because of the fact that we have 6 different tag types, we introduce a multitask learning approach, which transforms our model in the following way. So basically, the final 2 layers are repeated for each task, and all the other layers remain shared. Now, going to the results, I'll first describe our setup. We use an ablation study to compare the different modules. We start with a base module, which only has the newly trained embeddings and nothing more. Then, respectively, we add the character embeddings, BERT, and the in-domain pre-trained fast embeddings on top. And finally, we also report, excluding the newly trained embeddings, we report this only for cases where we have BERT enabled. And of course, we also provide one single task run, which has all the modules enabled, just for the sake of comparing to the multitask approach. All of these different configurations can be seen to the right. We have in total 8 configurations per language. And finally, we also compare the documents and multi-segment split types. So as you are probably aware, one sequence in this challenge has different segments. So naturally, we tried first using segment level and document level, where the document level basically uses all segments. But unfortunately, the segment level proved to be performing quite worse. So to this end, we implemented a multi-segment approach, where we are using more than one segment, but most importantly, not all at the same time as in the document level. And furthermore, we also report fine-tuning of BERT. So yeah, now this also must be mentioned that we only report this for the multi-segment split because unfortunately, due to computational limitations, our document split is simply too large to be handled by our computational resources. Now going to the results. Here you can see our first table where we have the multi-segment level for the French language. Here we can see several things which are also, I must know that they're visible in the other results as well. So here we see that our modules actually consistently outperform the baseline. We see that adding the character embeddings and BERT always improves results. Still, we see that actually all modules contribute one way or another. They improve results when a module is added on top of the configuration. However, sometimes we see that excluding the newly trained embeddings actually helps. This is mostly visible for the case where we have all modules enabled. And finally, we see that fine-tuning BERT does not really boost results, as the better results here are actually without fine-tuning at all. This is also visible. The same conclusions are visible in the fine-grained type for the French multi-segment level. As well as the document level. However, for the document level, we see that actually the document level performs quite better compared to a multi-segment level. This is also visible for the German language as well. We have the same observations there. And however, for German, we actually see another thing that our models actually struggle on the sparser annotation. So this is mostly visible to the right of the table in the nested tag type, where we have several results where the model is not able to predict anything, and this is even more visible in the multi-segment level, where you can see that most of our configurations are actually not able to be predictive at all. However, for this type of the multi-segment level for German, we see that actually here the difference is that the fine-tuning actually seems to be working better. And our best results are actually here with fine-tuning. And finally, as some takeaway messages, some final thoughts that we discovered during our studies. Firstly, the data importance. We saw that inconsistency is a problem. This is mostly visible for the English language, which, of course, as you all know, didn't even have a training data set. We also saw that the document level split works best. So basically the sequences that are the longest and therefore has most information work best. Then for the transfer learning applicability, we saw that each of the embedding modules that we implemented actually contributes one way or another. They improve the results. However, we see that the character and level and BERT in particular were the most important, that they were providing the highest benefits basically. On the other hand, the fine-tuning of BERT actually did not prove to be any helpful most often. And finally, for the multitask approach, we saw that often was the case that single task runs outperform multitask runs. However, after tracking it, we saw that this actually required roughly 2.5 times more time on average. So still the benefits and like it has pros and cons, basically the multitasking versus the single task. So yeah, with this, I would like to conclude the presentation, but on a final note, I want to take also the organizers, because both me and Giovanni think that you did a great job and we had a lot of fun during the participation. So thank you for this as well.